Section 1.2, Part B. So in this video, we're going to look at symmetry of functions. So graphs of equations can have symmetry with respect to one of the coordinate axes or with respect to the origin. So axis symmetry, x-axis symmetry, basically, here is your x-axis right here. And so if you notice above, you have part of the graph, and then below you have another part. If I was to flip the graph over, then this part is going to land on top of this part of the graph. If that happens, then we say that the graph has x-axis symmetry. And another thing to highlight here is notice that the x variable stays the same. But what happens with the y is that it gets the opposite sign. So it went from positive to negative. But if we fold the paper, this point will land on top of this one. A graph can also have y-axis symmetry. And this is our y-axis right here. So with this axis symmetry, y-axis symmetry, this part of the graph, if I fold it the long way, will land. So this part will land on top of this part. And notice here in your ordered pairs that the x's are the ones that are switching opposite signs. The y remains the same. And then the third one is the origin symmetry. And for the origin, this is the origin right in the center. What happens here is that it has both symmetries. So if we fold the long way on the y-axis, we would end up in this side here. And then you would fold on the x-axis, and so this part would land over here. So you have to do both symmetries to get that origin. If that happens, then we say you have the origin symmetry. And notice the values of x and y, they both change to opposite signs. So we can figure out symmetry by looking at the graphs, or we also have tests that we're going to be doing algebraically. So first, let's practice with the graphs here. So example 8, is there any symmetry for this graph here? So this is your y-axis, and this is your x-axis. And so notice that if I fold this graph on the y-axis, then this part of the graph would land on top of this one. So basically for the y-axis, we would be folding our paper the long way this way. Okay. So this graph does have y-axis symmetry. The second graph, this is your x-axis, and this is your y-axis. Notice that this part of the graph, if I fold my paper down this way, then this part of the graph would land on top of this one. And so we say that this has x-axis symmetry. Again, notice the values of the y's here are changing. We had a positive 2, now we have a negative 2 for this point. And for this example, the x changed from negative 2 to positive 2. That's going to be a key thing for us to figure this out without the graphs. So now here, the origin. If you notice here, if I fold the graph the long way, then this graph would land on top of this side of the graph. And then if I fold down, it would fall on this graph. So this is going to have origin symmetry. So again, for origin, we're looking at, does the graph have y-axis symmetry? And then if you apply the x-axis symmetry, does it land on that bottom part of the graph? And so here, if I fold it, it lands over here. And if I fold it on the x-axis, then it's going to land on this side. Or you can look at the points. You went from 1, 1, and then the values for x and y both changed. So if you don't have a graph, then we still need to figure this out, the symmetry, whether something has symmetry or not. So in this example, we're going to go ahead and work it out algebraically. So you want to check for x-axis symmetry first. And to do that, we noticed in the previous examples that the y values were changing from positive to negative. And so we're going to go ahead and do that. And this is going to be example 1 up here in this definition. So we're replacing y with negative y. So anywhere you see a y, let me just write the equation. Anywhere we see a y, we're going to replace it with a negative. So here I have y, so instead of y, I'm going to write it with a negative. And then we're going to simplify. So negative y squared comes out as positive y. And so we get y equals 6 minus x. Y squared 6 minus x. So in order to figure out if it has symmetry on the x-axis, this is your original equation. And this is your new equation. And notice that they are the same. If they're the same, then we say it has x-axis symmetry. So that is the test that you would do to figure out if it has x-axis symmetry. We're going to go ahead and just check the y-axis and the origin just so that we can see the process. So for number 2, for the y-axis, we're going to change the x with a negative x. So we're going to change x to negative x. And then let me write the equation. So anywhere you see an x, we're going to replace it with a negative x. So if we simplify, we get y squared is equal to 6 plus x. And so notice here that this is the original. This is a new equation after you simplify. And these are not the same. Not the same. Since they're not the same, then we say that there's no y-axis symmetry. And then the other type of symmetry is origin symmetry. And so for that, this is number 3, we're going to change both the x to negative x and y to negative y. So we're going to change x to negative x and y to negative y. So the original equation is y squared equals 6 minus x. So anywhere I see a y, I'm going to change it to a negative. And anywhere I see an x, I'm going to change it to a negative. Negative y squared is positive y squared. Negative negative is positive 6. And so if you notice the original, this is the original. And this is your new equation after we plug in the negative and the x, negative y, negative x. And you can see that these are not the same results. So we say that there is no symmetry in the origin, or no origin symmetry. Okay, so these are the 3 tests that you can do. Once you find that it works for one, you don't have to do the others. But we're going to go ahead and try all 3 again. So let's try the x-axis. So we're going to change y to negative y. So I'd like to write the equation down just so I can see it. So here y is going to be negative. We can solve for y. So and divide by negative 1. So we get y is equal to negative x over x squared minus 1. And so the original is up here. This is your new equation. And if we compare them, then we can see that they're not the same. Okay, so they're not the same. So there is no symmetry, no x-axis symmetry. Okay, so let's check the y-axis. We're going to change x to negative x. So anywhere we see an x, we're going to change it to negative x. And simplify. So here we get negative x. Negative x squared is negative, or is positive x squared. And then plus 1. Compare the equations. This is your original, and this is the new one. And you can tell that they're different. So these are not the same. So what that means is that there is no y-axis symmetry. And then last, we can check the origin. So we're going to change x to negative x and y to negative y. So here I have y. I'm going to change that to negative y is equal to negative x divided by negative x squared. So if we simplify, we get negative y equals a negative x divided by positive x squared plus 1 divided by negative 1. So we end up with y is equal to negative negative will be positive minus 1. So they're almost the same, but they're not quite the same. So not the same. So what that means is that there's no symmetry to the origin. A graph can have no symmetry at all. It can have symmetry on either of the axes. Okay, the next thing we want to look at is circles. A circle is a set of points x, y in a plane that are the same distance r from a point called the center. So here's your center. So from the center to any part of the circle, that's called the radius. And for the center, we're going to use h and k. For radius, we're going to use r. The standard form of the equation of a circle is given by this formula here. Okay, so we'll be using this formula where h and k is going to be your center. So let's go to the next page. Let's work on example 12 and 13, and then we'll come to example 11. So first I'm going to do example 12. I always like to write down the formula just so it's in front of me. Okay, and then I'm going to go ahead and write, in fact, let's do example 13 first. So I like to write the formula down, and then right below it, I'm going to write down our equation. Okay, so notice here, if we compare this, we know that h and k is going to give us a center. So we have x and x minus and minus, and then we have h and 2. So in this example here, my center, we can see that h is going to be 2. And then over here, if we compare, you got y and y minus minus. So k is going to be 3. So that's going to be your center. So notice here, if you had a minus 2, the opposite is positive 2. Minus 3, the opposite is positive 3. So you can look at it in that way as well. And then here we see that r squared is equal to 16. So if we solve for r, we get plus or minus 4. We're only going to use the positive since we're looking at the distance. So my radius is equal to 4. Then we can use these two things to graph the circle. So first, you want to plot the center is 2 and 3. So I'm just going to put a little dot here. And then the radius is 4. So the radius is going to give us the outside of the circle. So from the center, you want to go down 4. You want to go to the left 4. You want to go up 4. So let's say about over here. And then to the right 4. And then we can draw the circle by connecting those outer points. Okay, so that's going to be your circle. So let's go back to number 12. So here I have x plus 3 squared plus y minus 1 squared is equal to 4. So if we compare again, we have x and x, but instead of a minus, I have a plus. I need to make sure that this is in the standard form. So I can rewrite this as x minus negative 3. And notice that negative negative is still that positive 3. By doing that, then I have x and x, minus and minus. So that means that h is going to be negative 3. And then for the y, we have y and y minus, okay, is 1. And then the radius is going to be r squared is equal to 4, take the square root. So r is going to be 2. So again, notice that if you have a positive number, the center is going to be the opposite of that, negative 3. If you have a minus 1, then the opposite will be a positive 1. So now we can graph the radius is, so the center is negative 3 and 1, and then we have a 1. And then from here, we're going to go up 2, to the left 2, down 2, and right 2. And then we can sketch our circle. Okay, so now let's look at example 11. So the point 1, negative 2 lies on a circle whose center is at negative 3 and 5. So let's kind of draw a little picture here. So the center is negative 3 and negative 5. So this is the center. And then the point is at 1, negative 2. And it says that it lies on a circle. So the circle might look something like this. Okay. And it wants us to write the standard form of the equation. So in order to write the standard form of an equation, it's always a good idea to write this. So you're going to need to know what the center is. And we know that because they already give it to us. They tell us it's negative 3 and negative 5. Well, if we know r, then we can plug it in here. Let me just rewrite this as r is equal to something. So in reality, what we're missing here is what r is. We want to know what is r. So from chapter 1, we've looked at the midpoint and the distance. So you want to figure out, do I need to use the distance or do I need to use the midpoint? So for extra points, I'm going to give you for 2 extra points. On quiz 1, email me the solution. Okay. And so you should have my email in your syllabus. You can send it through Blackboard. So once you have your R, then all you have to do, and I'll give you an example here. Let's say you have your center was I'm just making this up, 5, 6, and your radius was 3. Then to write the equation, all you have to do is plug that information in. So you have x, your center here is minus 5 or 5, and then your k is 6, and your radius is 3. Okay. So once you find the radius in example 11, then you want to find the equation, and all you have to do is substitute it into the standard form. Once you are done viewing the videos, your notes online, at the very end of the notes, you're going to see some checkpoints. So these are just additional problems that you can try before you try the homework. And the good thing about this is that you can click on this link and it's going to take you to the solution for that problem. And it's also a video. So it's a video of that problem. So if you want to see extra examples,
sketch the graph of each
you
equation.
can also play it
Part
in
A,
Spanish.
3x